Okay, cool. Let's get started after figuring out our technical difficulties. Hi, I'm Felix Glaser. I work at Shopify. I'm a production security engineer. For those of you who don't have that work title, what we do is we care about everything that's below the application level. So we take care of building secure Docker images, deploying them securely, securing Kubernetes for old infrastructure, building our own secure kernels, rolling them out. So everything that's below the app level is what I personally find interesting. For those of you who haven't heard about Shopify, Shopify hosts more than 600,000 stores all over the world. So if you have recently bought from somewhere that wasn't one of the big marketplaces, then there's a good chance that Shopify was behind the tiny online store that you bought something from. So let's do a quick strawman poll here. Who has ever run sudo curl pipe sudo bash on their machines? Yeah, basically everyone here. Who has done that somewhere else than their laptops? Let's say like a production environment. Oh, at least one. And who felt good about it? No one. That was to be expected. Today we are going to talk about something that is very similar to running curl pipe sudo bash in production. For that, let me go back about 15 years. For those of you who've been in the industry for a bit longer, deploying on VMs should be a very familiar process. You installed and configured your VM, hooked up a DB to it, and that was your production system. It came with the advantage that it was at least virtualized, but it was really hard to roll out and to maintain because you always needed to SSH into boxes, needed to run commands, and well, the mutability of those VMs had a lot of downsides because replicating a VM to multiple VMs was a pain in the butt. And mutability is also the enemy from a security perspective, because everyone who got access to your VM could just install the software they wanted there. As soon as they were in for long times. They could gain access to your database, and well, at that point, it's more or less game over for you. But then Docker came around, and things changed for the better. Rolling out applications is super easy now. You just start a Docker container wherever you want it to run. In our case, I guess that's always Kubernetes. And it's super easy. You just take a Docker container, bring it from A to B, and run it again because we got rid of mutability. So this shouldn't be a surprise for you. You write some code, push it to wherever you host your code, build it with whatever you build it, and then you deploy your Docker container into your cloud. Well, this still allows for manual changes when people connect to your Kubernetes cluster. They can still run a Docker container from wherever it can create kubectl, create, run, edit it. If someone from outside your organization gets access to that, then it's game over. So I don't want to talk about that. But what can happen is that someone within your organization that has the authorization to deploy an image deploys something that they shouldn't. And here's where we come back to curl pipe sudo bash. Because Docker files are the new curl pipe sudo bash. Because let's say, what's wrong? Arguably, there's nothing wrong with this Docker file. And I don't want to bash Ubuntu here, but this Docker file has a lot of critical vulnerabilities and even more high and severe ones. So the problem here is not that you're deploying something that is by default malicious, but you're deploying something that is vulnerable just by aging. So even if you're deploying your image instead of a Ubuntu image, since we moved away from mutability, we now have immutable Docker containers. And as soon as you deploy them, you can't just run apt-get install unintended upgrades and just keep your Docker image up to date. That just doesn't work. So how do we fix that? What we need to do is we need to find a way for us to figure out whether a Docker container is okay to be run in production or not. And we could do that with a service that we just introduce into Kubernetes, and whenever we run a Docker container, we call out to that image, to that service, and that service decides whether the image can be run or cannot be run. So let's build this here together. So there's obviously two ways this could go down. We could either make our decision at runtime, which gives us the advantage that whenever we make the decision is accurate. Because we'll take the Docker image, do all of our checks on the Docker image, and then decide whether it's okay to be run or not. The downside of this is obviously that the startup time increases, I don't know, by like 2 minutes. If it's a big Docker image and you want to check for just for whether it's vulnerable or not. The other thing is that we could pre-compute our checks and then just store the result of those checks and just make sure that those results are what we want them to be. The downside here, obviously, is that things like vulnerabilities pop up every day, so we can never be 100% sure whether our data is as accurate as we want it to be, and we might need to go back and like recompute our checks every now and then. So what do we attach our checks to? So every Docker image is uniquely identified by its digest with a SHA-256. We take that, and the Docker reference is where your image lives in the registry. We take those two pieces of information and just PGP sign it, and then we store the signature for every successful check that we execute. So what would be the ideal place in Kubernetes to put this service? Well, it needs to run whenever an image gets deployed. So it needs to run on create, edit, update, and so on. So the correct place for this is an admission controller. And I guess every one of you has, if they've ever used Kubernetes, used an admission controller under the hood, because they do useful things for us like image poll always and other things where they go in during admission and decide whether they should change how they get deployed or whether they get deployed. What we're doing here is not a mutating admission controller, just a validating admission controller, and that admission controller is called Kritis, and it's open source. It's it's the piece that we're going to use to base all of this on. So Kritis gates our deploys now. So we now have a way, now we have a service called Kritis that we can go out to and ask whether the image is okay. And if it's okay, we'll pull it from our registry. If it's not okay, because it lives, for example, outside our registry, then it won't get pulled. That gates us from like someone making an accident, like accidentally pulling in an image from somewhere else, and also from someone maliciously trying to pull in an image from somewhere else. So where do we store those PGP signatures that we created? There's a service called Grafeas, and Grafeas is a metadata server that stores a lot of different kind of information. You can have attestations, which is the correct term for what I called signatures up until now. But Grafeas holds a lot of can hold a lot of information about images. It has build information, like which packages were used in the build, which base image was used. You can store all your vulnerabilities from your vulnerability scanner in there. So this is the ideal place for us to also store our attestations in there. So now we have two critical pieces of our infrastructure already. We have our admission controller Kritis, our database Grafeas, but we don't create attestations yet. And this is where Voucher comes in. Voucher is written by my team and me at Shopify, and it's a customizable attestation creator. So after an image is built, we call from our CI/CD pipeline out to Voucher, and Voucher then reaches out to different parts to find out whether the image is okay to be deployed. So for example, it goes out to our registry and just sees where we can pull the image from our own registry, because only we can push it to there, so we know it's our image. We make sure that the container doesn't run as root. We check that it comes from the correct pipeline, that there are no vulnerabilities in there. We use Clear and Google vulnerability scanners. So Voucher supports both of them depending on whether you run on GKE or not. So it reaches out to the vulnerability scanner, sees whether there are vulnerabilities. You can configure which vulnerabilities you are okay with. Let's say you're okay if they are like medium and lower, then we can just ignore all of them. Obviously, you could also reach out to your CI and see where your image has, like, let's say, 80% code coverage in there and only deploy things with code coverage. So cool, we have now also a place that creates attestations. But I guess every one of you runs different images and different specifications for securities in different tiers. So let's say you have a production tier where you only want your most secure images to be running, then you obviously want them to not run as root, have no vulnerabilities. But you also want to give your developers a place where they can just try out anything and like just play around and create new software, which then later on gets more and more tight the more it moves security-wise, the higher it moves up in the layers. So now we need something that decides where we want which attestation to be required and where not. This is where policies come in. Policies are just YAML specs where you can say what you want to be whitelisted, because there might be images that you generally trust, right? You don't want to like pull in the Nginx source code, build it yourself. No, just like trust the developers that they do their job correctly for Nginx, and then you can just specify images to be whitelisted. you can have different enforcement modes. Like if you're rolling out something new, you might only want to log violations to policy, but not block images from being deployed, because then you can just like bring up your infrastructure somewhere else, see that everything runs smoothly, and then flip the switch to block and audit log. Evaluation mode is obviously require attestations because you want attestations to be there. And then you can have different attesters. So for every check that Voucher executes, we have a different so-called attester. And under this attester, your signatures will be grouped. So in this case, we would only require the one called name. Yeah. So obviously, this is a little too widely scoped. If this holds true for the entire project, that's why you can have policies per cluster. The same goes there as before. The only difference here is that you pop in the line cluster admission rule, and then you say like only run it for that cluster, so that you can have a different set of rules in every cluster that you run in. So we talked about vulnerabilities before. There's a special one, the package vulnerability policy, where you can say which severity of vulnerabilities you're fine with. So, for example, this blocks everything high and above. And since sometimes there's no fix for CVE yet, you can whitelist them and thereby then circumvent it from being blocked if you're fine with that vulnerability being deployed in your environment. So now we can reach out to our different projects and different clusters and find out which attestations need to be present where. So everyone here who works as an SRE should ask that question, right? Like, but what about emergencies? What if I need to go in and fix something right now and I don't have the time to like build a new image, fix the vulnerability before I fight a fire? This is where break glass comes in. You can just on the podspec annotation, you can say break glass true, which will then tell Kritis that even though the required attestations are not present, it'll still let you deploy something. So if this is the case, that you can just pop on an annotation onto everything that you deploy, how does that help in the first place? Because like now we either need to secure that piece of information and then not tell anyone, which would be security by obscurity. So like if anyone can just add the break glass annotation, what is it good for? Well, the idea here is that whenever you break glass, it'll create an audit log. That audit log gets picked up by your pipeline, whatever you use, and then you send out notifications to PagerDuty. PagerDuty then pages CloudSec, so your team that is responsible for running all of this. The other thing that we are thinking about is gating who can actually add that annotation to break glass, so that the Kritis admission controller will only accept that annotation from a specific set of users, so that you can like gate it that way. Okay. why, let's look at why this might not be super easy to roll out. In case it wasn't really clear, those attestations only work on containers that are specified by their SHA. So I think that a lot of you are still deploying with tags, but this won't work anymore if you want to use binary authorization, because the Kritis submission controller only is able to look up an image in Grafeas if it can find it by its SHA. So you need to make sure that your infrastructure is able to handle that. Yeah. You might want to whitelist a lot of things in the beginning and then iterate over them and then throw them out bit by bit. There's a cool thing though. There's a plugin called Resolve Tags. It's open source. It's part of Grafeas. And that allows you to deploy with a tag. And what it does is it actually reaches out to your registry or to the registry where the Docker image lives, then resolves the tag to a digest, replaces it in your YAML, and then ships the YAML that has a digest instead of the tag. That might help a lot of you when you're trying to roll this out. So what have we achieved and what is left to do? Well, what we've achieved is we created a system where we rule out an entire class of vulnerabilities that are introduced by vulnerable Docker images that have code that is vulnerable. What we don't defend against right now is that stuff still can get vulnerable over time. So what is really critical here to do is that you run in your own infrastructure a vulnerability scanner that scans all your images regularly so that you can be sure that none of them are vulnerable, stores that information in Grafeas, like once a day, once a week, I don't know, and then use the vulnerability policy to make sure you don't deploy stuff that has become vulnerability over time. So to sum this all up, this is basically the new way of securing your deploy pipeline. You push something, it gets built, Voucher creates attestations for it. Those attestations get stored in Grafeas, from where Kritis at deploy time will pull them, make sure that they match the entire policies required in your cluster and in your project, and only if they work, it gets deployed. And if something breaks glass, it'll page your team about it. Cool. Do you have any questions? Do we have a microphone? If not, just speak up and I'll repeat your question.
So, it seems like you mentioned 3 core components here.
Yeah.
Voucher, and the Grafeas and Kritis, right? So, are they... Sorry.
You get a mic.
Sorry. Okay. All right. So you mentioned 3 components, core components, Voucher, Grafeas, and Kritis. So I just wonder if all of them were developed by Shopify.
No, only Voucher is developed by Shopify. The other 2, Grafeas and Kritis, are developed by Google. But they're all open source, so if you want to roll it out in your environment, they are all open source and you can all just deploy them.
Thanks.
Do you mind passing on the mic?
Hi. I have a question about the attestations. Understand that you create the attestation based on the information available at the point of creating it. But let's say, further down the road, as you progress on this work, you find other things that you can attest.
Yep.
How would that? I mean, and this can be like if a new vulnerability comes out, then you realize you have to attest a specific module or a specific version or subversions. How would you go back and then kind of how would that flow look like if you would have to reattest certain information about the images?
Okay, there are two answers to your question, right? Like, if you're doing something completely new, like let's say you didn't check beforehand whether your images run as root or not, and you want to roll out that, then you just create the you just need to go back through all your images, scan all of them again. There's actually a tool, if you go and check out Voucher, there's a tool which lets you do exactly that, go back and reattest like a bunch of images at once. The other thing is if a new vulnerability comes out, and that is unfortunately the case that happens all the time, you just need to run your vulnerability scanning continuously.
Okay.
Yeah. Otherwise you'll just miss it. Yeah.
All right. Thank you.
And the package vulnerability policy then takes care of this. If there's new information in Grafeas, it'll block it.
Thank you.
Just to try to clarify, how is this different to the Harbor project?
The Harbor project?
The Harbor with the container scanning.
Well, this allows you to do whatever you want to scan for, right? Like you can create attestations for anything that you want to use. This is not only about vulnerabilities. You could think of this as being the one piece where you can create anything that you want. For example, let's say you only want code to be deployed that was pushed by people within your organization that used that signed their commits. You could make that happen with binary authorization.
One question on the Kritis and then the Grafeas integration. When Kritis wants to allow or not allow some Docker image, what is the data it sends to Grafeas? It has to talk to Grafeas first and then decide, or it just relies on the image metadata?
So during deploy time, Kritis looks at the digest, takes the digest, goes to Grafeas, pulls all the attestations from there that it can find in Grafeas, takes them back, then looks at the policies to see which are required, and then it actually makes sure that your attestations are signed correctly, and then if all of them are, then it gets deployed.
So the image digest is the key for everything.
This image vulnerability policies, how are they maintained? If some new policy comes in, the image vulnerability policies, if there's a new, who maintains these policies? If there's a new policy published, there could be, this critical vulnerability be there in the Docker images. How does this policies be maintained? It's a open source thing that's, the list of policies available, or it's what we define?
Well, let's go back to. Well, policies are just YAMLs that your SREs or production engineers write and maintain.
Okay.
And the package vulnerability policy, you just specify and per cluster and then just leave it there.
Okay, thank you.
Cool. If there are no more questions, then thank you all for coming.